Hello everyone, welcome to the first video in a series of videos that I will be doing on electrodynamics. I am excited to teach this course because electrodynamics is one of those topics that tends to be seen as like this black magic sort of thing that's very mysterious. And so I'm excited to see, or at least I'm excited for the challenge of trying to break things down in a way that makes sense. So thank you for watching, and I hope to see you in my future videos. Okay, so what is electrodynamics? Essentially, what we are doing with electrodynamics is that we are trying to develop mathematical models of the electromagnetic force. So oftentimes when we talk about electric fields and magnetic fields and things like that, it can seem kind of mysterious, but behind all of that really is actual forces that we can physically measure. So I think that's something to keep in mind when we're talking about electrodynamics, is that we really are talking about these physical forces that we can experimentally measure, and then we develop mathematical models to model that force. The electromagnetic force, like gravity, is just one of the fundamental forces of nature. It's just a brute fact of the universe. So I want to start off with talking about gravity because it's a force that we're all familiar with. And one thing that I want to point out is that gravity is fundamentally kind of mysterious in that basically we know that if you have two masses, m1 and m2, that there's going to be a force of attraction between them. Now, as to why that is the case, like what is going on to like cause that attraction, I really don't know. I'm sure physicists are working on this, but as as an engineer, what I really care about is how does this attraction work? How can I mathematically model it? Not so much what is physically going on in the space between them to cause that attraction. And so there's this element of mysteriousness in that we're not really asking the question of why, but we're really asking the question more of how. And the how question is not as mysterious because really when it comes down to it, it's just let's do an experiment, let's observe the forces and measure them experimentally and develop mathematical models of that. And so you can actually do these experiments and come up with Newton's law of gravitation and actually compute the force between M1 and M2. And it's the same thing with the electromagnetic force. Yes, there's an element of mysteriousness as to like, okay, like why is this thing acting the way it's acting? But really, as engineers, we care more just about how is it acting and doing experiments and developing models of how that works. And so at the end of the day, what I want you to take home here is that our mathematical models that we're developing in this course really are about how the electromagnetic force works, not why. The electromagnetic force is more complex than gravity. With gravity, it's always attractive and it occurs between all masses. But with the electromagnetic force, it only acts on particles that have something or a property we call electric charge. Also, unlike mass, which is always positive, charge can actually be positive or it can be negative. And if you have two like charges, like both positive or both negative, then they will actually experience a repelling force. So to give you an idea of just the added complexity, let's say we have two charges, 2-point charges, Q1 and Q2. And they're separated by a certain distance, and we want to know what is the electromagnetic force between them. Well, it's a little more complex than gravity, and it depends on a lot of variables. So basically, if you want to know, if you have two charges, and you want to know what is the force F21, the force on charge 2, due to 1, it depends on the amount of electric charge, Q1 and Q2, not surprising. The distance between them, also not surprising. But in addition, and here's where the extra complexity comes in, it also depends on the velocity of Q1 and Q2. So if they're moving, that changes the force. But there's even an additional layer of complexity. If you start accelerating Q1, then you start having, it can actually change the force between them. So there's a lot of extra added complexity that comes in with this. And so that's why we don't have just a simple law like we do have like Newton's law of gravitation. Instead, we have Maxwell's equations, which are more complex. But I wanted to highlight for you just some of the variables that go on here when we're actually trying to model these forces. So in this course, we are going to learn all about Maxwell's equations. I'm not going to take the time to explain all of this right now, but essentially, Maxwell's equations, they describe how this electromagnetic force works. And they describe it in terms of electric and magnetic fields. And we will talk more about the concept of a field. It's basically a mathematical concept that we invent in order to simplify our calculations. But really what's going on underneath the hood is computation of forces, or the electromagnetic force between charged particles. So yeah, for the remainder of this course, we're going to really dig into how all of these four equations describe how the electromagnetic force works.